Okay, so today we're talking about the difference between sequences and exponentials. And you're going to be saying to yourself, why couldn't we do that before? Because this is going to be so much easier than those sequences. But before we get to that, we have a lot of review, and I found that the kids weren't awesome at this. The first problem everybody gets right, so why don't you see if you can do this one on your iPad. Do this problem. I'll be asking you in a moment to turn it my way, and I'll be checking you to see if you're doing it right. Then I'm going to assign you a partner. Today it's going to be something different than I normally do, and I'm going to pause for a moment while I do that. Okay, I usually describe this as get the clump alone. This is the clump. We get it alone by adding 1. And then we have x to the 2/3 equals 1. And then we have to put it to the power of 3/2. All right, and I know this is cruel to start with on a Monday morning, but 1, square root of 1 is 1, 1 to the 3rd is 1, but the answer is not 1. I bet you almost everybody said it was 1. How many of you caught something special about this problem? Anyone? Ah, a couple people, and what was special about it? We did a square root on both sides. When you do a square root on both sides of an equation that has a variable in it, then that means, and listen now, the answer is not just the plus minus. A lot of people get this wrong because they think, oh, so I just put a plus minus on here. No, you don't. What you really do is the absolute value of this. Now, I know you're thinking, well, doesn't it in the end just have a plus minus? On this problem, it does. But on a problem like this, where you do absolute values on this side, you'll have to solve it and know how to solve it. Do you get? I just put a plus minus on the 8. I do absolute values. It makes it different. Do you remember how to break this up into 2 equations? X plus 5 equals 8, and x plus 5 equals negative 8. Okay, that's what I mean when you are breaking things down with absolute values. All right, there's going to be another one coming later where this happens, and you need absolute values here. So let me just throw in an absolute value question. Let's say it was this. Solve it. Absolute values just simply break into 2 equations. I'm going to pause for a second while you try that. I'd like you to compare it with the kid sitting next to you and see if you get the same 2 answers. There's 2 answers, and it's not plus and minus something. Otherwise, you did it wrong. Okay, here we go. You should have broken into 2 parts and said x plus 4 equals 9 and x plus 4 equals negative 9. You need to know how to handle absolute values because later you're going to have the same thing except it'll have been to a power of like 3/2, and then you will put it to the power of 2/3. Oh wait, that wouldn't actually cause it. If you had a power of 2/3, and then you put it to the power of 3/2. When you put something to the power like that, that's got an even root, it brings in the absolute value. And then you need to know how to get this. Minus 4, x equals 5, and minus 4, x equals negative 13. Raise your hand if you had those 2 right. Okay, good. Now let's see if you can handle the next one. This is the kind where you got to get the bases the same. Once the bases are the same, then the powers will be the same. I'll pause for a second while you try that one. You've had time to talk it over, hopefully. Have you checked it out with the person next to you? Yeah. If you haven't already, just do a quick check. You change the 1/9 to 3 to the negative 2. Because 3 squared would give you 9. That makes flip it 1/9. Okay, so now that these 2 bases are the same, now I can set the exponents equal to each other. Gentlemen, thank you. And that has to equal that. So 3x has to equal negative 2. And then I'm going to say x equals negative 2/3. There we go. Raise your hand if you had it right. Okay, that's most of you. Any questions on that? Like, wait a minute, how'd you get this? All right. Then this one, you need a lot of simplifying here. then you have fraction in your problem. You know how to clear the fraction. We've practiced that on that top 20 sheet. Clearing fractions is important. Get rid of the denominator, you know. So then in the end, your answer is x equals, because it's the solve for x. X equals, and I'll warn you that your answer has a y in it, because you can't get rid of the y. So there's a y in your answer. X equals something, something, y. All right, I'll pause for a second while you give that one a shot. Okay, here we go again. You should have started by simplifying the 3 and the 2. At least it's all, sorry, 3 and the 12. That's all way to start. And so that's going to simplify it. 3 goes in here once, 3 goes in here 4 times. I have my new answer has a 1 on top and a 4 on the bottom. Now I'm going to simplify my x's. Do you get that these guys are not happy where they are, so I move them down, and these are not happy where they are, so I move them up? Another way to do it is to just subtract the -3 minus the -5, which means x to the +2. So that would mean on top. But if you want to do it the way I just suggested, you would move these guys up to the top and say this is x to the 5 on top, and the x to the 3 goes to the bottom, and then you do the simplifying, and either way, you end up with x squared on the top. And then that y is still on the bottom, equals 2. Then what did I say about the fraction? You want to do what to the fractions? Take them out. Clear them. You multiply by the denominator. That's how you clear fractions. That way, that cancels that. And now I've got x squared alone. Which as far as 8y, I'm getting close. How many of you had x squared equals 8y in your work at some point? Okay, good. That's almost everybody. Then the next part is I square root. I go square root on both sides. I hope that rings a bell. If you do square root on both sides, you have to do absolute value of x. And that will cause you then on this kind, it is simple. If it's just an x, then you can say plus and minus 8y and the square root of it, which you could either write this way, or you could write plus or minus 8y and the square root that way. Either way, it's the same thing. These two, one of those two. How many of you had that right? And how many of you forgot the plus minus because you're a normal human? All right, I do it all the time, so don't feel bad, but try to watch for it. When you're square rooting, it's so easy to forget. Okay, this one. I told you to kind of watch out for these because they have a tendency to not work when it's all done. Now, if you just go like this and say, oh yeah, that's right, he said these don't usually work, and you say undefined, or you say no solution, I will not give you the credit. You have to prove that there's no solution by finding the solution and then sticking it back in and seeing if it works or not. And I'll warn you, sometimes it does work, but a lot of times it doesn't. So how do we start? Square both sides. Everybody take it from there, and there's no absolute values when you square both sides. It's if I square root both sides that I get absolute values. I'm going to pause while you give that one a shot. Okay, so here's what you do. Once you've squared both sides, this has gone away, and it's just x plus, or x minus 4, sorry. X minus 4 equals 5x plus 1. You've been solving that equation since 6th grade. You just subtract x from both sides, and then I have negative 4 equals 4x plus 1, and then I subtract 1 from both sides, and negative 5 equals 4x, and then I divide by 4. And x equals negative 5/4. The problem is that solution, when you actually put it in, you put in a negative 5/4 here, will make a big negative number, where even if you add 1, it's still a big negative number, is underneath the square root. And that's not okay. So you can't have an answer that when you put it in causes an imaginary number solution. There's no real solutions. This is probably a really good way to answer this question. If you said no solutions, I'd accept it. But also I would have accepted it if you just gone like this. Cross this out, EXT. That's the abbreviation we use for extraneous solution. Okay? All right, this one is a lot. That one had a lot of little catchy problems, but that's what the tests often have. Since we only have like 8 or 12 questions, we usually throw the ones that are more complicated at you. That's why I'm doing a lot of practice of that. All right, today the intention was that I wasn't going to need to take that long on the review, but this was hard and a lot of people were getting them wrong. So I'm going to wait and give the homework quiz I was going to give today tomorrow, but you're not going to get any like long practice session before it. Okay, so be prepared for the homework quiz. I'm putting it off one more day to tomorrow. And now let's, this would be the same basic thing. We would add 5 to both sides, makes this 16. And then what's the catch? You're going to put it to the 3/4. And what's the catch? No, there's no plus minus. It's not a plus minus. It's the absolute value. Absolute value of x plus 2 equals this. Okay, I'm going to even put it in there for you so you get to see. See, you need the absolute values here, and that's why we practice solving these absolute values. So then 4th root of 16 is 2. 2 to the 3rd is 8. Now you solve it from there. Do you get how that problem became an absolute value problem? Because as soon as I did a even root, that's what made it into an absolute value. And then get the two answers and compare them with the person across from you that I paired you with, or in front of you on the end rows. I'll pause where you try that. Okay, I did the hard part here. I think you could have handled that part really no problem, right? You guys, let me check. 27 to the 2/3 power. Hold up on your hand what the answer is. Nice. Almost everybody's holding up a 9. Nice work. Okay. Because why? Cube root of 27 is what? And then you square it. So this is the root. This is what you do like the regular power. After you do the root, you do the 3rd root, makes 3, and then you square it, makes 9. What if I'd have thrown in a negative in front? That'd be a third thing to do to it. Would you make it negative 9? No. Make it 1 over 9. Good. If I change the problem to that, the answer would be 1/9. Okay, good. Now back to this guy. You should have added, you should add 2 equations. X plus 2 equals 8, and x plus 2 equals negative 8. Other than that, one little negative, the equations are identical. Then I subtract 2 and I get x equals 6, and I subtract 2 and x equals negative 10. All right, how many of you had those right? Okay, good. And from here, it gets to be some easy ones. This, you get that you just subtract the exponents, right? So this becomes a to the negative 4 minus x equals a to the 10th. Do you get why it's easy from there? Because that equals that now that the bases are the same. So go ahead and set up that equation. Compare it with the kid next to you. I'll pause for a second while you try that one. Should take a few seconds only. Okay, so you should have said negative 4 minus x. Oh, sorry, negative 4 minus x. Minus x is equal to 10, and then you should have added, quiet please, 4 to both sides. Negative x equals 14. Don't make me come back there, please. Thank you. And then x equals negative 14 is your final answer. Any questions? All right, then this one, again, just in your head quick. You should be able to get the answer. Turn it my way as soon as you got it, and I'll tell you if you got it right. Yep. 3 people with it already. 4 right, 5 right, 6 right, 7 right, 8, not negative, 8 right, 9 right. Was that's a 1? Okay, you're good. That's right. That one's right. That's right. Okay, good. Pretty much everybody's getting it. Square root of 25 is 5. I'm sorry if it's too slow. I have to move on. 5 to the 3rd is 125. And then there's a negative. You do not make it negative 125. The negative in the power makes it flip 1 over 125. Okay, moving on. This is finally the new stuff. Okay, and I needed to review that other stuff because that was the hard stuff. This is actually extremely easy. This is what we did before. You remember we'd have a starting value of 500 and then like a growth factor of 25%? You remember those? You should. And here is where you put the start. You put the start value right there. And this is your growth factor built in, and I personally would rather have you write it as 501 plus 0.25 to the x. Now, why do I want you to go to that extra step of having a plus in there? Just because when they ask what the growth rate is, a lot of people say 125%. If you have it broken out, it'll be really obvious. 25% growth rate. It's even more important on the next kind, like this, where you have 1 minus 0.15. I get that that's the same as 0.85. Please do not use a 0.85 in your formula, or when I ask what the decay rate is, you will think, oh, the rate's 85%, and it is not. Do you get that if it's written this way, it's really obvious what the decay rate is? That's why I want you to use in your answer here, y is the same as f of x. You could use f of x if you would really rather. The initial value goes here, the rate goes there, and it's always to an x. Try that one. Write down what you think it is. If you are just trying to watch me do this, you're going to remember 10% of it. That really is awful, awful retention, and you will not be able to do well if you're only remembering 10% of what the teacher teaches you. But if you do the problem, you don't have to finish it, you just have to write me the equation. Because to finish it, really, you'd have to know what x is. What is the power? Like, how many days should we do this problem for? And if I said 2 days, you'd put a 2 right here. But we're not doing that right now. You just want the formula. All right, would you please compare with the person I paired you with for today? See if you got the same thing.
Great answer.
You are right. You need a y equals to be an equation. Okay, so I'm going to have a 75 here because that's the starting amount. And then it is true that 1 minus 0.15 is 0.85. But I'd really rather have you do this. Why? Because then later, when they ask what's the decay rate, you'll say 15% instead of saying 85%. Okay, good. Actual question. Calcs are allowed. Grab a graphing calculator. I wrote these questions, so they're obviously good. Jim's starting to notice that the cockroaches are taking over his house. We don't have these in Minnesota. I think they don't like cold. But there are cockroaches in other parts of the country, lots of them. And if you leave food out especially, cockroaches can become really bad because basically you're feeding the animals and then they multiply. Okay. He takes a census. I thought that was kind of a funny way to think of it. And determines that he's got a population of 18. He reads up and determines that it will grow, it meaning the population will grow by 15% per week. Write an exponential function in this form. So you just have to write me an equation. Y equals, and what do you start with? The starting value, 18. And what do you put here? Is it growth or is it decay? So you go 1 plus, and then what's the rate? 1 plus 0.15. There you go. And what does it need to be an exponential? It needs a what in the what? An x in the exponent. Let me say that again. To be an exponential, that's the whole topic for today. To be an exponential, you need an x in the exponent. You've had x's everywhere else, but we haven't done much where x's are the exponents. That's just this new thing we've been doing for the last 4 days. Yes?
Wouldn't you do like the 1 plus 0.15 divided by something?
Good question. Nope. This problem was done in weeks. And therefore, this is 15% growth per week. If that had been 15% annual growth, then we would have needed to divide by 52 weeks in a year. Get the difference? This was 15% per week growth, so we don't have to mess with that, and you don't want to do that. Don't make these problems more complicated than they already are. I get what you're saying. If this had been an annual rate, we would have needed to divide by 52 here, but we're not given an annual rate, so we can do it that way. And then how many will there be in 3 weeks? Just stick a 3 in there. And I hope you know how to put this in a calculator. Y equals 18 times 1.15. And yes, you can put the plus, or you can just say 1.15. And then you say caret power of 3 weeks. 3. And that'll tell us not how many weeks, but the population, and it'll be a decimal. Yes? Good question. Your answer will work just fine even though your calculator is in sequence mode. If you wanted to put this in a graph, then you'd want to change it back to function mode. Remember, what she's talking about is if you hit the mode button and you look down to the fourth thing, there's sequence mode and there's function mode. I don't think we're going to be using sequences too often, but I think we might have a few more. So I guess I wouldn't change your calculator out of sequence mode quite yet, because this will work just fine out in the main screen. When you are on the main screen, it looks like this. And this one was 5 times with a 5% growth, okay, but it's the same idea. So I'm going to do this one, and it was 18 to start with, and you say times, and then you say 1 plus 0.15, 15% growth, to the power of, or end the parentheses, to the power of 3. Enter. And there's your answer, 27.37, so about 27 cockroaches at the end of 3 weeks. They do grow really, like, they can be lots of cockroaches living in a house, and they are nasty, no doubt. Actually, rabbits and some animals like that grow a lot faster. Their populations are really big because they are the happy meal of the great outdoors. Everything likes to eat rabbits. Like, seriously, ridiculously number of. No, they have to have tons of babies because they're figuring that only 1 out of their 10 babies are going to survive. So they need to have tons of babies. Same thing happens with fish. Fish, have tons and tons of babies. If they actually all survived, our lakes would be completely, like the fish would all die actually, because there'd be so many fish that they'd eat everything in the lake and there'd be no more food and then they'd all die. But a lot of them get eaten when they're babies. Tons of fish, like way worse than the rabbits. Fish will have like 1,000 to 1, or no, probably like 100 to 1 ratio of little tiny baby fish to actually fish that make it to like age 10 or whatever. Okay, last one. Application. Sally Mae is going to start brushing her teeth. Yay, finally decided it was important. Her dentist told her that she only needs to brush the teeth that she wants to keep. She starts by brushing for 5 minutes. If she continues to increase her brushing time by 5% per day, how long will her brushing sessions be after 12 days? Well, obviously they'll be longer than 5 minutes. The question is, how many minutes would they be? You like Sally Mae's picture down there with, I think somebody took Brittany and then did a little bit of Photoshop to make her teeth disappear on top. Looks pretty scary. On the topic of stars whose teeth were terrible beforehand, Ben Affleck and Tom Cruise. You should look at them before they had their teeth done. Like, you do a Google search of before teeth. Tom Cruise before teeth or something like that. It's Find me a picture of Tom Cruise. Oh, great. You got pictures?
You started before us. Oh, I got it.
They have the internet. That's how. All right. Okay. Some people can type really fast. All right. So I think you get the point. Brushing your teeth is good. Y equals, and people that have really twisted teeth usually don't make it in Hollywood. But if you want to be a villain, it'll work out pretty well. There are a few, but they're usually not the leading actors or actresses. So anyway, that'll keep the dentists in not just dentists, but the ones that straighten teeth. Orthodontists in business for a long time, I'm sure. Although someday they'll have a way of doing it without the actual braces. They even have that Invisalign stuff, and that's getting more popular. Do you guys know anybody who used Invisalign?
Yeah, a lot.
A bunch of people. Okay, did you? Oh, you used it. So? It was annoying, okay.
Basically, it's
Okay. But you never had to have those things stuck to your teeth and never had people like cranking them tighter and all that good stuff. So overall, would you do it again? Or would you have the regular braces done?
I prefer Invisalign to normal braces.
Okay.
Well, they're just there, because like a lot of people in LA use them, because you can't like have like for work.
Oh, I suppose, yeah. They can't have the braces on during the movies and whatever, so good point. All right. So y equals the starting amount, which is, wait a minute, it started with 5 minutes. And then the increase was 1 plus, he's doing more, right? 1 plus 0.05. And then if I want to make it an exponential, it needs a what in the what? An x in the exponent. There we go. So y equals, oh, actually, that is the equation. We're done. The only thing is, if I want to actually find the answer about after 12 days, where do you think I put the 12? In the x. See how easy this is? I think it's way easier than all those sequences that we did. But that other sequence stuff is good for that learning that notation that you need to know for the states test. And I'll tell you, it also can be on the ACT test. They can give you equations like these on the ACT test. It's in the list of topics they can use. So anyway, I'm glad you know how to do that now, but I would personally always choose this way because it's just so much easier to put in the calculator and everything. You don't have to change to a strange mode, and instead of u sub 23, you can just type in a 23. Okay. All right, and that's all I have for you for today. Your assignment on today's is a little bit on the long side. You may want to ask your teacher. I personally am going to assign the evens on this assignment, except at the very beginning. There's a few odds I want you to do because the 1, 2, 3, 4, and 5 all kind of flow nicely together. So I want you to do 1, 2, 3, 4, and 5, and then after that, you can just do the evens on this assignment. And that's all I've got for you.